Yes, hello students, welcome back to our channel. So in this video we are going to talk about one more important compound of chlorine, that is hydrogen chloride. Its formula is HCl. So generally we call it as hydrochloric acid. When this hydrogen chloride is treated with water, it forms hydrochloric acid. So directly let's go for the preparation of hydrogen chloride. So generally we prepare hydrogen chloride by using sodium chloride and sulfuric acid. When sodium chloride is treated with H2SO4 at the temperature of 420 Kelvin, it forms sodium hydrogen sulfate, also known as sodium bisulfate, with HCl, hydrogen chloride. This is the compound we need. And one more reaction we have, that is when this same sodium hydrogen sulfate or sodium bisulfate, when it is treated again with sodium chloride, but now at the temperature of 823 Kelvin, please make note it is 823 Kelvin, now it forms sodium sulfate with the liberation of HCl, hydrogen chloride. Clear? So this hydrogen chloride can be dried by treating it with concentrated sulfuric acid. This HCl can be dried by treating with concentrated sulfuric acid. We have seen in our previous videos also that concentrated sulfuric acid is a good drying agent. Clear? So here also concentrated sulfuric acid is used in order to dry hydrogen chloride, which is obtained by treating sodium chloride with sulfuric acid and NaHSO4, that is sodium bisulfate with sodium chloride. Clear? So this is regarding the preparation of hydrogen chloride. So now let us look at the properties of hydrogen chloride. So properties means generally how this hydrogen chloride reacts with water and how this hydrogen chloride reacts with ammonia, NH3. Let us look at the reaction with water. Reaction with water. Yeah. So when hydrogen chloride is treated with water, it forms hydronium ion H3O plus Cl minus ions. Clear? So when HCl, hydrogen chloride, when it is treated with water, it forms H3O that is hydronium ion, plus Cl minus, the chloride ion. Now let us look at the reaction of HCl with NH3, ammonia. Reaction with ammonia, NH3. What happens when HCl is treated with ammonia? It forms NH4Cl. NH4Cl, ammonium chloride. Clear? So these are the two reactions with water and ammonia. Now let's go for the uses of hydrogen chloride. So uses, the first use is it is used to extract glue from bones. It is used to extract glue from bones. This is the primary use of hydrogen chloride, and secondly it is used a lot in medicines. It's used in medicines. We are generally we take any tablets or injection and back side of tablet contains the composition of the tablet. If you just read that, you can get this HCl in most of the tablets. Hydrogen chloride or in form of hydrochloric acid. This HCl will be available in almost all of the medicines. Here, this is the primary use. This HCl is used in the medicines. And the next important use from the point of view board examination is aqua regia. It forms aqua regia. It's also known as royal water. Yeah, aqua regia is also known as royal water. So now, what do you mean by aqua regia? Aqua regia is the 1:3 composition of 1:3 composition of this is concentrated HNO3 and concentrated hydrochloric acid. Clear? So this is the ratio, 1:3 ratio. That means 1 unit of concentrated HNO3 and 3 units of concentrated HCl. When you mix that in this particular 1:3 ratio, the solution that you get is known as aqua regia or royal water. So now, why we are giving most importance to this aqua regia or royal water? What is the use of this royal water or aqua regia? It is this aqua regia, it is used to dissolve noble metals like platinum and gold. Clear? So this aqua regia is used to dissolve noble metals like gold, platinum. It is very economic. The metals like gold and platinum, it is very, very costly, very, very economic. So, in order to dissolve this gold and platinum, we use this combination of concentrated nitric acid, that is HNO3, and concentrated hydrochloric acid in this particular ratio. The ratio of 1:3. This particular ratio, we call it as aqua regia or royal water. It is used to dissolve gold and platinum. Let's write the reaction for this one. When gold, is it visible? Let me write it upside. Right, upside. No problem. Okay, so let us look at the reaction with gold. What happens, how it gets dissolved. So gold AU, when it is treated with aqua regia, that is 4H plus NO3 minus plus 4Cl minus, what happens, it forms AuCl4 minus plus NO plus 1. Yeah. So this is the reaction involved when the royal water is treated with gold. It forms AuCl4. So this gold is get dissolved and that can be separated out. Clear, student? So this is the main use of hydrogen chloride. So the next concept is interhalogen compounds. So if you just look at this word interhalogen compound, what does it mean? Interhalogen, it means that between two halogens. Clear? So the compound which is formed due to the combination or composition of two halogens, we call it as interhalogen compounds. Let me write it. Compounds formed between Clear? So the compound is formed between two halogens. We call it as interhalogens compounds. So in order to write this, let me take some example of ICl, IF7 we have. Okay. So now, why we are writing iodine first and chlorine next? Why we are writing iodine first and fluorine next? It depends on, in order to understand this, let's go for this one. Okay. So down the group, what happens? As you go down the group, atomic size increases. Atomic size increases. Clear? So as you go down the fluorine, chlorine, bromine, iodine, as you go down the group, atomic size increases, whereas electronegativity decreases. Clear, students? We have fluorine, chlorine, bromine, iodine. Clear? As you go down the group, atomic size increases, whereas electronegativity decreases. Fluorine is the smallest halogen, but it is the most electronegative element in the periodic table. So in order to write the interhalogen compounds, the first halogen should be of higher in size or lower in electronegativity, and then the second halogen should be of lower in size or higher in electronegativity. Clear? So this is the rule we need to follow in order to write the interhalogen compounds. The first element should be of lower in size or higher in size or lower in electronegativity, and then it should be followed by the next halogen, which is of lower in size and higher in electronegativity. Clear, students? So now we have some types of interhalogen compounds. Interhalogen compounds. So now we have XY or XX dash, also you can take two halogens, XX dash 3, XX dash 5 and XX dash 7. These are the four formats of interhalogen compounds. So now let's take some example for this one. So we have XX1, that means two halogens. We have ClF, chlorine, bromine, iodine. Clear? So these are, I need to do example. For XX3 type, we have ClF3, BrF3, whereas XX5 we have IF5 and BrF5, ClF5 is possible, whereas for this one XX7 we have only one, that is IF7. Clear, students? So these are the four types of interhalogen compounds and some examples for this one. So when we compare the reactivity of interhalogen compounds and that of halogens, which is more reactive and which is less reactive, we have the answer of, we have this interhalogen compounds ICl and we have the halogen ClCl, which is more reactive. Coming to the reactivity, this ICl, that is interhalogen compounds, are more reactive when compared to the normal halogens. It is because these are more reactive. These are interhalogen compounds and these are simply halogens. Clear? These are more reactive and these are less reactive. Why it is? It is because of this is a weak bond. Weak bond which is formed in two different halogens. Interhalogen bond in which the bond is found between iodine and chlorine, whereas in case of halogens it is found between chlorine and chlorine. This is compared to interhalogen compound. Halogen compound has a strong bond. Clear? So due to this, it is a weak bond, so it is easily broken. Clear? We can easily break this interhalogen compounds bond. So this is more reactive than halogens. Clear, students? And we have some interhalogens compounds. Let's look at the preparation of this in some interhalogens compounds. Preparation of okay. So when you treat chlorine with excess of fluorine, when you treat chlorine with excess of fluorine at the temperature of 573 Kelvin, you get ClF2. ClF3. So this is one of the interhalogen compound, and when you have equal volumes of iodine and chlorine, you get ICl. When you have equal volume of chlorine and fluorine, you will get ClF. And let me take one more example from bromine. And bromine, when it is treated with excess of fluorine, here you get BrEF5. Clear, student? These are some interhalogen compounds and their preparation. Now the last part of interhalogen compounds. Yes, this is regarding the properties of interhalogen compounds. Now we have got the information regarding what are interhalogen compounds, their preparation, and their some reactions also. So now we are looking at the properties of interhalogen compounds. They differ in their properties because of the combinations are between two different halogens. Clear? So first of all we have ClF. It is the combination of chlorine and fluorine. It is a colorless gas, whereas BrEF is a pale brown and a colorless gas, whereas IBr is a black solid. So now the fourth property is IF5, BrF5. They have square pyramidal shape. We are talking about their shapes, and then they are always covalent. Halogen and interhalogen compounds are covalent. Covalent means they share the electrons in order to form a bond. The bond is formed due to the sharing of electron between two different halogens in this case. So these are covalent because of due to their less electronegativity, Clear? So, and the magnetic property is diamagnetic. All interhalogen compounds are diamagnetic in nature. Clear, students? So this is regarding interhalogen compounds. So we are ending up here.